Kata dia orang gelap betul kan?
Okay, good afternoon everyone. Assalamualaikum.
Waalaikumsalam.
Okay, can we start our class now?
Sure, Doctor.
Okay, so this is our last class. Okay, finally. This is our last class for this semester, for this subject. How about other subject? Is this week your last week for the lecture?
Some subjects.
Yeah.
For some subject. Alright,
Some subject didn't finish yet, Doctor.
alright. So you have some few topics, right?
Yeah. Few more topics to
Okay,
go.
Same with our subject. Finish with lecture, but we still have lab test 2 and also quiz 2. So we discussed that in the end of our lecture today about the other two evaluation. Okay. So we start now. So I will open the PowerPoint slide. Okay. So today topic is introduction to parallel system. In this topic, before class, I have just shared with you the Edpuzzle for you to know more about the taxonomy for parallel system. And then during class now, some slides and interactivity using Go Formative. And lastly, in the end, we do have some Kahoot. Okay, so please try to do this add puzzle after this. All right, so this is our last lecture for the homework. The question is, what are the differences between Android OS and Linux
Doctor,
OS? Yes.
Doctor, excuse me, I'm Wilson. I want to ask if you have already shared that because I just checked and it's not in my place.
Sorry, what is your question again?
I'm asking that if Doctor has already shared the Add Puzzle link because I checked my Add Puzzle just now and it's not there yet.
Oh, really?
Yeah,
Same,
no,
Doctor.
yeah, I don't see it here.
Okay. So maybe I have clicked the wrong group. So I will double check about that.
Okay,
Okay.
thank you, Doctor.
Okay, thank you for your so I will check again. Sorry for that. Okay. So same with the last topic, right? Mobile computing.
Yeah, Doctor. In my
Okay.
puzzle, there's no mobile computing also.
Okay. So for
Doctor,
that,
I think need to enter the class code.
for the app puzzle.
Yes. This week the ED puzzle is HPCA part 5, right?
Yeah, sorry.
Uh, this week minggu ni punya puzzle ialah HPCA part 5 kan? Tajuk.
Okay. So I will check about that. Okay. Okay. So I hope after the class or maybe afterwards, I will try to check what is the problem with app puzzles. I think I have assigned with the right group. Maybe, yeah, the group is wrong. I will double check about that. Okay. So thank you for your concern. So now we look at your homework. So thank you again for submitting the homework that I gave last week. And these are one of the selected answers from group ZA, To Yan Zuan, O Teng Hee, Lim Fai Fei, Yang Yuhan, Muhammad Arif Fitri, Nur Kalisha. All of you is here today?
Yes, Doctor.
Yes,
Doctor.
Okay, glad to hear your voice. Okay, so this is your answer. Let's check. So yeah, so mostly the main differences between Android OS and Linux, based on the developer and the power management, of course, the architecture supported, the file system, the library used. If you still remember, the library used by Android slightly modified by Google in order to adapt with the use of less power of CPU technology in mobile platform. I hope you still remember about that. And others, the Android also has Velvet Virtual Machine. Okay, good. So I hope others also have done a good job too. So for today's topic, before this we look at OS in the mobile computing platform, where we can see that like Android OS play important roles in helping users to run their program. But one we need to also to think about to improve the performance of the computer, and one way to improve the performance of the platform, whether it is a mobile platform or in this case for computer platform, laptop or desktop or server, we need to add parallel ability or computing in order to improve the processor performance. So today's topic, we look at the introduction for parallel computing or parallel system. So this is the outline for today's class. The first one, we look at how the processor processors are organized, which is based on the famous taxonomy. If you search this taxonomy, you can find a lot of information about this one, Flynn taxonomy, which is related to parallel system. The second thing, we look at non-parallel processor, one of the category in the Flynn taxonomy, which is SISD. And then the third subtopic, we look at parallel processor, which is SIMD. What is SISD, SIMD? We will learn more about that. And lastly, we look at another parallel processor category, which is MIMD. Okay, now we move on to the first subtopic, which is Flynn taxonomy. So in Flynn taxonomy category, how the Flynn is the name of a person, okay? So how Flynn actually come with this taxonomy? So I would like to have my pen here. Okay. So for the category, they look at how many number of instruction streams, and secondly, how many numbers of data stream. So each category in Flynn taxonomy, they will have at least one instruction stream. So this instruction stream, we can call it as IS, instruction stream. And at least they also must have one data stream, or in short, we call it as DS. Okay, so this is the diagram that show the instruction stream. The instruction stream come from the control unit. If you still remember, control unit inside the CPU, and the instruction stream go to the processor, and this is the processing unit. Okay, and then there is also data stream, which is related to the memory unit. Okay, another way to make this diagram simple, you can find from some textbooks. They make a simple diagram, which is this is control unit, and from the control unit will be the instruction stream, and the instruction streams will go to the processing unit, and then there will be a retrieve and also retrieve and load, store the data from the memory unit. And this one, the connection here is called data stream. Okay, so in Flynn taxonomy, at least each category must has one instruction stream and also one data stream. Move on. Okay, so with that, the Flynn organized the processor. Okay, it organized the processor into 4 categories, 1, 2, 3, and 4. The first one, they call it a single instruction stream. Instruction stream, single data stream. So this is SISD. What do you think will be the second one? Single instruction. Okay. M stand for what? What do you think?
Multiple.
Yeah. So the second one is single instructions, multiple data stream. Okay, this is like the conventional one. This is also popular. This one is not very popular. It's not really used, which is multiple instruction, single data stream. This is not very popular. And the last one, which is also popular, is multiple instructions and multiple data stream. Okay, so this category is called Flynn taxonomy, and this taxonomy is very popular. You can find it a lot. If you learn about parallel system, usually you will come across this taxonomy, which is how the processor is organized based on the data streams. Okay, that is the basic idea about Flynn taxonomy. Don't worry, we will look one by one inside that category. Now we look at the first category, which is non-parallel processor, SIST. Okay. This is for the first category, which is SISD, single instruction set and single data stream. You still remember what is this one? The box? What is the first one? What is the flow start? The instruction stream? Yeah, come from control unit. And then what is the flow here?
Processing unit.
Oh,
Okay, this will be processing unit. And from this control unit to processing unit will be?
Instruction stream.
Yes, instruction streams. And how about here? What is the box here?
kau study benda ni ke?
Study. Memory unit. And this one will be?
Data stream.
Yeah.
Data streams.
Okay, good. So my question is, this system has parallel processing capability, yes or no? What do you think?
No.
Why no?
It should come from memory to processing unit.
Okay. So yeah, you can say that you can see that there is only one single stream, right? Okay. So this system is not parallel category because the architecture for system with parallel capability must have more than one processing unit. So we can see here there is only one processing unit. So this cannot be parallel processor. So this one is the first category in Flynn taxonomy, which is SISD, which is not parallel processor. So this is like conventional computer, which is based on von Neumann architecture, which is only has one single processing and one single data stream, like what we learned so far. Mostly in our class, we look at this type of model. Okay, so basically it is about uniprocessor and has execute a single instruction and it operates on a single data stream. So the example for SISD is uniprocessor. Okay, only one processor, not multi-core. Now computer mostly come with multi-core processor. So yeah, your laptop is not anymore SISD. SISD is only for uniprocessor. Okay, so this is the first category for Flynn taxonomy, which is there is no parallel capability in that system because there is only one processing unit. So now we move on to another type of category that has the parallel processor, which is SIND. Okay. Okay, so for this one, I just want you to have some exercise. Please go to goformative.com/join and enter this code OCSEUS and then try to add the processing capability to the architecture. Can you do that now? Boleh buat tak?
Boleh doktor.
Boleh eh? So, yeah. So this is the question just now. So how to draw? What do you think will be, you make a label here. Which one is you think control unit? Which box will be the processing unit? Which box will be the memory unit? And then you draw the flow from one box to another box. And then what is the name of the flow? Is it instruction stream? Is it data stream? Okay, can you do it now, please, everyone? So we are in the afternoon, so yeah, try to get some exercise in the afternoon. Yeah, within 3 to 4 minutes. It's quite an easy, straightforward exercise. Just to see your attention in class. Boleh masuk kan? You can go inside the Go formative. Is there any problem?
Boleh doktor, no problem.
Alright, good. So 5 minutes, please.
Doctor, I'm quite confused. So inside the box we don't have to insert anything.
Yeah. You can label this box. For example, the green box. What do you think it will be? Maybe it is CU, PU, or MU. So if you think it is MU, you just write MU here. Okay. You get that?
Okay, I get it.
Okay, good. Okay, I think we can discuss now. So what is the right answers? Okay. Okay. So I think yeah. Okay, some of you trying to get it right. So we not discuss now. So the answer will be like this. Okay. So how we can add the parallel processing ability is by adding more processing unit. So you can see here that before this, for SISD, we only have one stream. But in here, we can add more than one. So you can see that in this case, there are 3 processing units, and also there are 3 memory units. And come from the control unit, they go to the processing unit, and then they have storing or retrieving data to memory unit. So this is how you can add parallel capability in the existing system, which is to add more processing unit, and for each processing unit, you can add more memory unit. So I think this one, sorry, this the green one here should be with this one, the third one. Okay. So any question about this? Okay. Should I proceed? Okay.
Okay, doctor.
Okay. Good. So to add so like I said before, to add parallel capability, you can add a more processing unit. Okay. If there is only one single stream of instruction from a control unit for multiple processing, this architecture is called SIMD, single instruction, single unit. So it means that there is a control unit here, and the stream is only one stream here. And this one stream, it goes to multiple processing unit. This is actually PU. Okay. PU. And for each processing unit, there will be MU. Or in here, LM is called local memory. Local memory 1. And also this one is local memory 3. Or we can also say this is MU, memory unit, the same thing. So this is the second one, and this is the third one. The multiple data stream. Okay. So don't get confused. This data stream is only come from one control unit. So if the data stream come from one control unit, so the data stream is single. But that single instruction go to multiple processing unit because it involves different data. Okay, so let's say this is a big program to like for example for rendering for animation where it has a lot of data to render. So the data will be divided among the 3 memory here. So let's say this is the rendering process, but the same instruction. The instruction is to render the data to make a 3D model, for example, but it's involved different data. So this architecture is called SIMD, single instruction multiple data, since it comes from a single control unit. So it will have single that instruction stream. Okay. My question here is why it is also called loosely coupled. What do you think? Loosely coupled, not tightly coupled. Ada idea tak? So loosely, tightly coupled, tightly coupled. Tight is means that
Because it can carry its own processor.
okay, and its processor with its own.
Memory.
Yeah, correct. Okay, so called loosely coupled because it has its own processor and also its own memory. Okay, so that's why good, thank you for your answer. So that's why it call it as loosely coupled. I really highlight this one to differentiate with another category after this. Okay, good. Okay, so how to check whether your processor can support SIMD or not? If you try to check before this, pernah check tak? Saya tak pernah tahu. I mean first time dengar SIMD.
First time dengar.
First time Okay. So SIMD ni is related to parallel system. So how to check? So I just show with you. I keep searching the tools to check what is the information about our processor. So one of the option is to use Core Info. Okay, so you can try to download Core Info and then run in your command prompt. So I will show you. So I have download Core Info in my computer. So this is my download, and then I extract the file. So to run that, you need to use your command prompt. So open your command prompt. After this, you can try download first. Okay, and then how to run that command. This is exe file. Okay, the type is exe file. So let me check the type. Properties of the file. So the type of the file is exe file. So it can be run in your Windows. And the description here is dump information on system, CPU, and memory topology. Okay, so this, since my computer is 64-bit, so how to run is that you need to know the location of the exe file, and then your computer, my computer is 64-bit, so info 64-bit, and also the type of the file, the execution file type is exe. So I run that. Okay, so you can see that it's like Linux command prompt, means that it is based on command to run the app. So these are the information that you can find from using that Core Info. Basically, these are the information that you can find. So I just go through to see the instruction set for SIMD. So you can see that the short for SIMD is SSE23, and this is the version of it. And you can see that in my computer now it supports SIMD extensions. It means that if you have a programs that need to be run based on SIMD capability, okay, it means that the programmers has developed the programs so that the programs can be run in the SIMD architecture. So you have to check your computer, whether your computer can support that or not. So in my computer, it said here, it support SIMD extensions. Okay, so any questions about this? So you can try maybe after this. Yeah, boleh cuba tak lepas ni?
Boleh.
Boleh So get to know your CPU better after this. Okay, so that is the examples how to check whether your computer can support SIMD architecture or not. So it means that if there is any program that developed based on that architecture, so you can run that program. Okay, so now I move on to see the examples of the SIMD. So they are under SIMD. You can see that there are two examples for SIMD here, which is vector processor, and the second one is array processor. You can search more from the internet what is vector processor and array processor. It is something that involves this architecture, of course. It has multiple data streams and single instruction. I move on to the category, the fourth category in Flynn taxonomy. We have go through SISD, SIMD. We do not go through MISD since it is not popular and there is no many usage about that. So what is MIMD? So there is two types of MIMD. First, we look at the type which is tightly coupled. Okay, so MIMD is about this one. If there are multiple streams of instructions for a number of control units, where each instruction stream for a control unit is feeding to its own PU, what we can call this category. So this category is called MIID, and it can be tightly coupled, okay, if there is a shared memory for this one, okay. So wait the program to respond. Wait for a moment. So what is the examples of this architecture for MIMD? The examples of MIMD is called symmetric multiprocessor or SMP. Something wrong with my PowerPoint. Let me close the PowerPoint so that we can open back the PowerPoint. Okay, so far we have looked SISD, and then we proceed to SIMD, and then we see that my computer can support SIMD, and now we would like to see what is the SMP. Okay, so this one, so we can see that for the MIMD is quite big. The category is quite big. We can see that first it divided into two, which is shared memory and also it has shared memory, which is tightly coupled, and the second one is distributed memory, which is loosely coupled. First, we look at this one, shared memory, where they share their memory. Of course, the idea is that. So it has two examples here, symmetric multiprocessor, and also non-uniform memory access, NUMA. NUMA ni is quite popular. You can find these terms sometimes when you search information about computer. So it actually relate to memory access. Okay, we look at after this. Okay, So first we look at SMP. What is SMP processor? So SMP like the short form for symmetric processor. Let me check. Symmetric processor. Okay, it has these characteristics. Okay, it has two or more processors of comparable capacity, which is the processor is quite similar, and the processor shares same memory and input output. So if you look here, this has multiple control unit. So that's why you has a multiple instruction stream. So the number is until n. And also this is data stream for n processing unit. And the idea here, because it is tightly coupled, because all of the processors here share the same memory. Okay, this is more explanation about SMP architecture, where you can find the processor here, multiple processor, and then they share only one memory here, only one memory, and then they also can has link to the input output. Okay, so this is the key here. Memory access time is approximately the same for each processor. So this is the key for SMP, the access time. So how about the second one, which is NUMA, non-uniform memory access. So it means that this memory, the access time is not the same for each processor. So this is one of the architecture in your computer. Some computer can support NUMA and some computer cannot support NUMA. So you can check that also in your computer. Okay, for example, just now I have opened my code info. So if you scroll down to the code info, you can find that there is some information about NUMA. Okay, boleh nampak kan? Can you check? Boleh nampak tak?
Boleh.
Boleh kan? Okay. So this is the status for my computer, which is no NUMA nodes. So it means that my computer cannot support this architecture. It cannot support non-uniform memory access. It only can support the first type, which is, if you look back for the SMP just now, the SMP is, the access time is approximately the same. So my computer cannot support, which is the memory access is not the same for each processor. Okay. So we almost finished the Flynn taxonomy, where we have talked about uniprocessor, which is SISD, SIMD. Then we go to the shared memory, which is the first type, tightly coupled for MIMD. The first one, they have the similar memory access, which is SMP, and similar multiprocessor. And the second one, it doesn't have similar memory access. We call it as non-uniform memory access. So now we look at another type of MIMD, which is quite popular. Okay, you must know, I think when we learn more about parallel system after this, maybe in other subject about parallel computers, I think you will learn more about this one, distributed memory, which is loosely coupled and based on cluster. An example of it is cluster. So this is the example of loosely coupled MIMD, which is cluster. So I just want to imagine what is cluster. If you want to get idea about cluster. Okay, you can imagine, okay, there's, for example, this is your lab in FTSM. Okay, we have programming lab, programming 1, programming 2. We have a big lab in FTSM. We have about 70 pieces in one lab, mostly for learning programming. Okay, so for examples, in that lab, they have 70 pieces of computer. So this one will be computer 1, this one will be computer 2, and this one will be computer 70. Okay, and then this computer, you imagine, this is the lab, the whole lab. When you, maybe next year you can come to FTSM, UKM, you can go to this lab and see our big lab here. So in our lab, they have 70 pieces, and then all of this lab is connected using interconnection network. Okay, so they are connected together, all these computer in the lab. This one, it can call as cluster as they are in the same location. Okay, it means that in the same network, and most of them have the same OS. You can see that all of them here, for your programming, they based on Windows. They connect together using Windows, and then you can divide your tasks into all these clusters. Okay, so imagine there is a master node here, and then it can distribute the tasks. Let's say there is a big task here, it can distribute the task among all the computers here, and then when they finish doing the task, they will return back the results into the master node. And it is quite powerful if you have this ability. It means that you have the PCs, a lot of PCs in one location connected with the network. So you can install a special software for cluster, and then you can use the power of one lab, in this case 70 PCs, in order to process your tasks. Okay, so this is the examples of cluster. Okay, there is another, let me check. Yeah, it's not many more. How to make this cluster to become SMP. So you can go back to your, I hope you still open your Go Formative, since it has 2 questions there. Okay. Can you try the second question here?
Yes.
Okay. How to make this cluster to SMP? You will buat try in 2 to 3 minutes. Okay, so maybe we can continue to do it. So I just begin to explain. Okay, good. I can see that you are doing that. Yeah. So maybe I share this one. If you can see my screen. Yeah, how to make this cluster to become SMP. So as we know that cluster is loosely coupled, which is the processing unit has their own local memory. So if you want to compare it with the SMP, symmetric processor, the symmetric processor, they share the memory. So to change this, you need to combine all the memory here to become shared memory. Yeah, to become shared memory that here. And then there is no network between them because it is in symmetric processor, it is in one big computer. In cluster, it is distributed. It means that you can find the processor, the multiple processor physically. Okay, like I said before, in the lab, you can find there are 70 PCs in the lab. So that type is a cluster and the task is distributed into the cluster. It is connected by network. But for the symmetric, all the processors and all the memory is shared together and they are in one place, which is in the same computer, one big computer. Okay, so good. Thank you very much for your doing the exercise today. So I hope you get the main idea, the differences between the cluster, which is a loosely coupled, the distributed one, with the tightly coupled, which is the SMP. Okay, good. Thank you for doing the exercise today. Okay, so I would like to proceed. There's a few slides before we break. So the another architecture, just now I show you the examples of cluster, which is the cluster in one area. How about if the cluster, the computer is not in one location? Okay. Okay, maybe this computer in Penang, maybe from USM, University Science Malaysia, and maybe this server is in UPM, okay, and maybe this one is from UM in KL, University Malaya in KL, and this is from Sedang. So you can see that these resources is not in one location. They are come from multiple locations and they are come from a collection of computer resources. It can be a server, it can be a high performance computer. So this one, we call it as grid computing. Okay, so this also called distributed system because we distribute, like say you have a task here, a computer here that can distribute the task into the resources and it's involved a large number of files. Usually if it's involved a research base, for example, to calculate DNA, to model a DNA, or something that weather forecast, something that need heavy use of processing, they can use the grid computing. But grid computing is closed. That means it's only can be used by the participation resources or organization. Let's say it is from UM, if it is from UKM or UM, the person from this organization only can use this grid computing. Okay, they need to participate in the grid computing. So this is the examples of grid computing. which is from multiple location. If you compare with a cluster just now, this one same location. But both of them, cluster and grid, this we call it as distributed computing, distributed system, where the task can be distributed among the PCs or computer resources. Okay. And lastly, before we go to Santai and have a break, we would like to see that actually the Flynn taxonomies has been recently been updated. So if you find from the internet, mostly the Flynn taxonomy will until here. SISD, SIMD, MISD, MIMD. And then under MIMD, there will be shared memory and there will be distributed memory. And just now we learned about distributed memory, distributed system, clusters, and also grid. And if you talk about supercomputer, from the textbook here, Taxonomy of Computer Architecture, Essentials of Computer Computing, this book, Essentials of Computers. Let me open back there. It said about the supercomputer is under a new category, which is SPMD. So SPMD is single program, multiple data. So for this architecture, the SPMD consists of multiprocessor, each with its own data set and program memory. So the difference is that it has not instruction, but it has program. They call it as program, not instruction. So it is not very important to know more about that. I just want to let you know that supercomputer is under another taxonomy group, but the most important thing is that these four types, SISD, SIMD, and this one, MIMD. Okay, any questions before we go here? Yeah, okay. So before we break, 5 o'clock already. So after this, we go to another type of distributed system, which is cloud computing, which is quite interesting. So before we break, I just want to share with you about being holistic. Okay, so university now really want our students, when you graduate from UKM, you get the job. Okay, we want you to get the job. We really hope you get the job. So in order to get the job, you not only to be good in your results, but you also need to be holistic. What does it mean with holistic? Okay, so you has knowledge, but you also need to have psychomotor skills. So if you want to know examples of that, psychomotor skills is like your lab Linux. Are you able to use operating system like Linux? Okay, so that is example of psychomotor skills. It means you can use that technology. The knowledge, we test your programming skills, we test your knowledge about that particular topic. But in the psychomotor, we want you to do it. If you can do it, so you achieve that objective. And also other things, social responsibility, values, attitude. Okay, in your final year project, we also check your attitude. It's part of the carry mark, your attitude, your professionalism, communication. So how we check your communication? Based on mostly from your presentation. So if the class has the presentation or group work, so it will be that part will be evaluated. And problem solving, of course, we have projects actually for mostly of the course. So because they want you to be holistic, you to have this kind of skills so that when you go outside in the working area, you will be a good worker. Okay, lastly, do you know how to calculate your CGPA? Yes or no?
No.
No.
Tak pernah cuba? Nak tahu ke?
Tak.
Nak.
Saya tunjuk sekejap ya. We'll give you, before we break, few minutes, I'll show you. Maybe you can play around with that. Okay, you can open, you can search CGPA calculator, and then after this you can make your own Excel file and try to make your own CGPA. So, for example, here you can put your, you know your credit hours, right? Tahu kan credit hours? So what is the credit hours for TM, our class, platform technology? How many credit hours?
3.
3. Good. Because TM 2033 end with 3. So the credit hours is 3. For your programming, TK 114, the credit hour is 4. And then you have statistic, PR 1713, 3. And then others, maybe you have 3, 3, 2. You also have 1, right? LMCK is 1 credit, right? Your LMCK. Betul ke?
Yes. Yes.
Yeah. So then you can do your simulation. What happen if you, for 4 credit hours, what happen if you get C, for example, okay? If you get C, you can see that your CGPA will be your pointer 3.04. So if you get A minus, calculate, sorry. Calculate your CGPA, it should be higher. Yeah, what happened? Hang up. Okay, just put 3, 4, 3, 4, 2, 1, 2, 1. Then maybe you get A minus for your platform, A minus for your statistic. This one you get C plus, for example. Chitra, maybe you get B. At MCK, maybe you get C minus. So what is your CGPA? Still 13 So tak cukup This one you get B. Calculate 16. Okay lagi. Calculate C. Okay. Okay, 19. 2.5. So you can see that, okay, if I get at least B, okay, most to get 3. I need to get at least B plus, for example. You can get 3 pointer. Although this one is 1, but it's not play big. But if you get gay, what happens? Yeah, is your improve. So please do join your SIG. This one you can get A because there is no exam, just presentation and participation in your MCK. It will improve your CGPA as well. So, okay. Faham ke ni CGPA?
Faham.
Okay. So every semester you can try to do your simulation and try to at least get a target for every semester. Okay, that's all before we break. So we break about 10 minutes. After this, we will continue with cloud computing. Okay? I will share with you the QR code.
Doktor, ada benda black box ni tengah halang QR code. So tak boleh scan.
Masih halang lagi ke?
Yang box kat tengah tu.
Doktor, masih lagi.
Apa? Ada box apa lah, saya tak nampak. Dekat skrin saya clear, tak ada apa. Ada box eh? Ada box lagi ke?
Dah tak ada lah.
Alright.
Doktor. Invalid QR code ya, doktor?
Kejap. Sorry alah. What happened Sekejap sekejap. Okay tak?
Ada box lock lagi.
Saya pun tak faham. Tak pasti daripada mana datangnya. Sebab in my computer tak ada apa pula.
Maybe doktor boleh scroll ke bawah sikit.
Scroll.
Bawah sikit lagi. Okay.
Okay. Sekejap.
Bawah lagi. Okay. Tapi masih invalid.
Oh.
Doktor invalid lagi.
Doktor kecilkan screen.
Okay.
Alright, like that.
Tapi ada yang nak buat manual tu. Sekejap
Okay doktor, tadi tu dah boleh.
Dah boleh dah. Okay, cuba sekali ni. Boleh tak?
Okay doktor, dah boleh. Terima kasih doktor.
Alright. Okay, can we continue our class? Okay, maybe we let your friend. Yeah. So, we're not going. Okay, so I will continue our class with our next topic, which is cloud computing. So I just let your friends done the manual things first. So I give you the introduction for the cloud computing. So I think you have heard a lot about cloud computing. Do you know what is cloud computing? Siapa boleh cerita? What is cloud computing? Any idea about cloud computing? Something in the cloud? You want to try? What are the examples of software that you use based on cloud computing?
Google Drive.
Google Drive.
Good. Okay. What else? Ada lagi tak?
OneDrive.
Gmail.
Okay. Yes. Correct. Gmail, Google Drive is one of the categories for cloud computing, which is software as a service. Okay. So you only use them using the browser. You don't have to install, for example, the Gmail. You can log in to your Gmail account and you can get access all the functions for Gmail. Okay, you can give emails, you can reply emails. So that is about one type of cloud computing category, which is software as a service. So software as a service, we also have two categories for cloud computing, which is infrastructure as a service, and another type of cloud computing is platform as a service. Okay, so yeah, maybe after the end of the class, I will open back this one. Okay, for the attendance. So I would like to continue to open the, yeah, hang already my computer. Okay, so for cloud computing, what you should know about cloud computing is an hypervisor. Okay, I think most of you have installed VirtualBox or at least or VMware, where you try to use operating system on top of another operating system. So you need another layer. That layer we call as virtualization. I have problems with my computer. Okay, so I continue with the cloud computing. So why we need to know about cloud computing? Because the supercomputer, some of the parallel computers or supercomputer is actually very expensive. Okay, millions of dollars is if they are so big. So that's why we can have a cheaper solution, cost-effective solutions for high performance computer. And the alternative for high performance computers is cluster, grid, and cloud. Okay, so these three technologies we can put under high performance computing or HPC. where the main idea of using high performance computing is actually to solve difficult problems. And this problem require massive amount of computing data. Because of what? Because they have numeric scientific applications, or you have to do a complex modeling and simulation like climate, and also we have a big application like web servers for Google and e-commerce for Amazon. Okay, so for this topic, we try to further understand the main characteristic of one of these three technologies, which is cloud computing. Okay, briefly, we will cover all of this. What is the definition, the deployment models, the service model, what are the essential characteristics of cloud computing, and how we can create the share pool of resources, which is very important in order to develop a cloud computing technology. And lastly, another technology that is important for cloud computing is virtualization. So for the introduction, have you heard about Office 365? Have you heard about that?
Yes.
Yeah. Ada yang subscribe ke? Anyone subscribe? Or you are free in using that?
We are using the UKM email
For free.
for free.
For free, right? Okay. I also using that because my course, the Office version is because I need to use the new version of Office. So yeah, sometimes in some cases I use the Office 365. So this account is actually based on subscribe. It is on monthly basis. So this is you need to find the latest information. Maybe the amount here is different now. Okay. So what is the keywords from this advertisement? Okay.
Subscribe service.
Let us observe the advertisement. Okay, good. Ada ni. What else?
Virtually anywhere.
Virtual.
Yeah, visually anywhere.
Any device.
Okay, any device. Okay, good. So basically, these are the actually some keywords that contribute to the meaning of cloud computing. Okay. So how do we provide services to customer or end users? So like Microsoft, it has changed their trend from product based, before this you have to install the product, buy the CD, and then now they are going to service based. Okay. So that's why you can find here subscription service. If you want to use it, you can subscribe. Okay, they provide this service, and you can get things done virtually anywhere. It means that it can be downloaded into any laptop because it not the download. I mean it can be accessed using browsers. You don't need to download. You just can access using browsers. And any device, sometimes if it can support with browsers, tablet or anything that has browsers, so you can open the software as a service. So that is the keywords, and they show the trend to service based. And Microsoft is one of the driving force companies for cloud computing. Okay, so they have think about that, how to provide services to customer or end user. They have moving from product based to service based. Okay. So what is cloud computing? When we talk about cloud computing, you must know that it has certain criteria. Not all things that you find in the internet is cloud computing. Okay, so cloud computing is to provide, the main thing is services, provide computing services using virtualized computing resources. And one of the examples is Office 365, which is a software-based service, SaaS, software as a service. Okay, but remember, the cloud computing is not only involve software, but also hardware and also platform to develop and deploy software. So it is actually, cloud computing is not only about the software. So you can find that this is one of the definition of cloud computing. It is by using virtualized and modern web technology, cloud computing provides scalable, network-centric, abstract on-demand services. And the services are built on usage basis. Okay, I think most of you use the free one, but maybe in the future we are going to use some professional work. You might want to get something which is not free, because you want to get the services to make your work done. Okay, but the most popular definition for the cloud computing is given by NIST. This is an organization you can find for the internet. You find NIST and cloud computing, you can find this definition. This is very popular definition, has been used widely across the world. Alright. So what is cloud computing? Ubiquitous, convenient, on-demand network access. Okay, that is the keyword, a shared pool of configurable computing resources. It means that in cloud computing, they have a pool of resources that has been configured, of course, from the network, server, storage, applications, and services. And that services, you can rapidly provision and also release with minimal management effort or service provider interaction. Let's say you want to use 365, you don't have to call them, you don't have to pay online, you just have to log in, and they make minimal management effort. You just put in your, maybe in the future, maybe you have to put your credit card number for that, and then yeah, just a few steps you can get their service. Okay, so for you to understand more about cloud computing, you must know that they have 5 essential characteristics. So if that service has these 5 characteristics, so that you can call it as cloud computing services. And it has the models, 3 popular service model and 4 deployment models. So these are all the things related to cloud computing. So today we will look basically all these criteria of cloud computing. So basically from the definition, there are 3 main components, which is the deployment model, the service, and also the essential characteristic. So that if we look at the cloud computing deployment model, so it actually defines the purpose and the location of the cloud. So it can be public cloud. Yeah, the thing that you said just now, which is Google Drive, Gmail, or maybe like Amazon. You want to buy something from the internet, you want to buy the book from the internet. So that is, we call it as public. Public means that you can use it publicly. You can log in and you can access your emails, you can access your data in your Google Drive. That means by public cloud. Okay, so they sell the cloud services. Okay, So this is examples of the cloud services. Yeah, if you search more about this, you can find these examples like Amazon Elastic Compute Cloud, EC2. This is the compute cloud for Amazon. IBM also have their cloud. Google also have, and Windows Azure has their services platform. You can see that big company, they have their own public cloud where they offer to the public, maybe with some payment, of course, monthly pay basis in order to use their services. Okay, that is public. Another one is private. Private means that you cannot use that cloud. It only can be used by that organization. Okay, for example, maybe UKM, maybe in the future, they want to combine all their servers from all the faculties in UKM, and they make a pool of resources in UKM, and that pool of resources, they make a private cloud. Maybe in the future, they make a private cloud. So only can be accessed by that organization only. Okay, it can be in that organization, or it can be out of the organization. It means that it is located in the specific location, but only that organization can access to that private cloud. Another cloud that, okay, who actually can use the private cloud is actually the big company where they want to maintain their own data center. Like I said before, like UKM, they have many servers in many faculties. So maybe they want to make their own data center, maybe in the future. It's not easy to do that, but maybe it's one way to optimize our resources. But usually for the small to medium sized business, they don't really have their private cloud, but in the beginning, usually they will use the public cloud to store, to maybe to store their data, or to use virtual machine or server. Okay, my question, which type of business should adopt private cloud if they want to use cloud computing? A, B, C, or D?
A. D.
B. C.
Think again.
A.
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 D.
A, doctor.
Delta.
A, doctor. A.
B.
Tarik jawab A.
B.
Betul ke ni? Sekejap. Read again the question. Which type of businesses should adopt private cloud if they want to use cloud computing?
B.
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 Yeah, because if
Private.
private cloud is expensive. It usually for business, for a big company. I think B, C, D. Is it possible?
Yes.
Right? Yeah, so for startup business, private cloud can be expensive, typically modest economy of scale. So it's not an option for the average small to medium sized business. Okay, so I think this question you can have more than one answers. The first one is with critical information. Of course, public is also safe, like your email, but you don't know, right? Who can read your email? Betul tak? Do you know where is the location of your servers for your emails? For your Gmail? Do you know that?
No.
Tak tahu kan? So for the cloud computing, you don't know the physical thing. It visualized. Okay? It is visualized. You don't know the location of the server. You don't know who handled that server. It's virtual. It's in a cloud.
Critical info.
Yeah. Critical info, correct.
Inform.
Government automation, is it correct? Right. And also, I think if the business has huge money, they can also do this. Okay, so can I proceed? Yeah. So for the private examples, the cloud security actually one of the issue, especially for big company, especially in government sector. You have very the data is very secret. You don't want any form or something that can you simply use the data from that from Malaysia, for example, or from UKM. Okay, because we do have, like UKM, we have the profiles of the students. We don't want others parties to get the data that we have. So the cloud security, if you search from the internet, is quite trending, because for when we are using cloud, that is one of the main issues. Okay, the security. So for the hybrid cloud, some company they have private, and some company maybe something that not involved with critical information, they also use public services. So they combine for the critical information, they use their private servers, cloud computing, and for the not very critical data, they use public. Okay, so this is more about hybrid. Okay, like I said before, you can use based on your need. Okay, and this one is the community. The community is, I don't really use the community cloud. You can search more about the community cloud. It means that some organization has proposed develop a community cloud to be used by that community. Okay, for a certain purpose. Okay, this is examples of community cloud. This is in US, I think, where they make this cloud for the use of that community. Okay, so we have done the first part, which is the deployment models, community, hybrid, private, public. And then now we move on to the second layer of the definition of cloud computing. There is also need to know what are the services models for cloud computing. So the first models, which is cloud as a service. So in cloud, they make it as a service. What they want to offer as a service is in front. Okay, for example, here the first one is infrastructure as a service or hardware. So they offer hardware. The second one is platform as a service. They offer the platform. The third one is software as a service. They offer the software. So we look one by one now. So for infrastructure as a service, they provide the infrastructure. It means that, let's say that you don't have the infrastructure. I don't have computer, for example, but I need to do my work. So what you can do is that you can go to the Amazon, try to subscribe their EC2. Maybe you want to use the computer for 3 months to do your projects. Something wrong with your computer, and for 3 months maybe you can pay about 100 plus something. So at least after 3 months your job done. So you can get their service to get the virtual machine. This is actually the virtual machine, and you can install your OS, and you can install any software on top of the virtual machine, and you can use it as your own virtual machine. Okay, So this is the part of infrastructure as a service, and there are also other providers that provide you the infrastructure as a service. Okay, another thing is that the billing is based on the usage. So based on the provider, some provider put the CPU hour, how big your storage, and how the traffic in and out of your virtual machine. Okay, so this is the infrastructure of the service. You can choose your OS and you can admin your virtual machine, and you need to set up the elasticity and the failover of your virtual machine. Okay, this is another thing. If you want to try, you can search from the internet about Amazon EC2. Okay, it's quite interesting to try on, but sometimes they need your credit card number even you want to try. Okay, for example, I just need a not very powerful computer, so you can try to get this type of machine. Or maybe you want to have a big task, you need a high performance computer, so you can subscribe this type of virtual machine. Okay, so this the environment of the EC2. You can have storage, you can have database, you can have the virtual machine. So this is maybe not the latest interface. You can search more about the Amazon Web Services, what they can offer for the infrastructure as a service. So another type is platform as a service. So I have used Google App Engine before. Okay, what I'm using it to develop a mobile app. Okay, based on Java. So I don't need to install anything. I just have to copy paste my code into that platform, and then they run to me. They do others. They do in that. I can do in that platform. Okay, they provide me the platform, not only the infrastructure, but also the tools that I need for that development of the code. You can find more for other platform also, Windows Azure platform and force.com. So this is information about Google App Engine. Try to search more about that. This is Windows Azure application. Yeah, if you there is advertisement for you for training, try to get idea about what is Windows Azure application, because yeah, the companies are moving towards the cloud computing services. Even a big company, they don't have their own server, they use cloud services to put their data there. Okay, so lastly, we look at software as a service. This one is mostly focused on software, yeah, like the Gmail, the Google Drive, or any software that you can find from the internet. Okay, that you can use it through the browsers. You don't have to install. From the browsers, you can subscribe. And for example, the Go Formative that I use with you, it is one examples of software as a service. Kahoot also software as a service. Okay. Okay. My question, what is the time now? What is the time now?
5:50.
5:50.
5:50?
Yes.
Oh, okay, we only have 10 more minutes. Okay.
Yes.
So what type of cloud computing here? If you need to move your infrastructure to server cloud. A,
C. C.
yeah, C, right? Infrastructure as a service, because you want to move your infrastructure. Okay, so I think the essential characteristics is you can just go through after this. which is it is based on demand, must have network, is a pool of resources. You can resources can be rapidly and elastically provisioned, and it can be measured. It's like a tap or water. You have a meter for that. So for this one, it also has a meter to charge you how many you have used for the services that you get from the provider. Okay. So basically, these are the attributes for the characteristic of the cloud computing. Okay. So I want to move on to another two things there, which is I think quite interesting for you to know, which is what are the technology behind the cloud computing. Okay, how you want to create, how actually they create a shared pool of resources. So the two thing is that load balancing. It means that if you have a lot of servers, you have a task, so you need to balance the load between the servers. So in order to do that, all the cloud computing technology must have their load balancing techniques in order to divide the load between the servers. So if you want to need more information about load balancing, you can go through to this YouTube to find what examples of load balancing. Okay, I would like to go for this one, the virtualization hypervisor. Do you know that your computer support hypervisor or not? Do you have that information?
I have spare key in laptop and kalau siapa punya laptop dia ada, saya macam atas daripada 5 generation selalunya boleh guna virtualization, tapi i5 i3 boleh kot tapi tak sure lah. i5 i7 dan ke atas lah.
Betul. I think it's I agree with you. Mostly most of the latest processor, right? They support the use of hypervisors. But if you want to confirm with that, I think if you still remember our lab 1 BIOS, ingat lagi tak BIOS? You have, ingat kan BIOS? There is part that enable virtualization. Ada ingat tak? Kat BIOS there is a setting you need to enable your virtualization in order for you to install VirtualBox. I hope you still remember that. This is another way for you to check your virtualization, your hypervisor. So by running this code, you can also get the information here. For example, hypervisor is present. So of course, in this i7 that your friend said just now has the hypervisor. So it supports the virtualization. So what is the virtualization? So I would like to go through just a little bit now. You want to know more about the virtualization, you can watch this video. But I just want to go through the diagram here. Okay. So in virtualization, in cloud computing, they have a resource layer, a pool of layer here. So in order the virtual resources to get the use of these resources, they need to have this layer, virtualization layer. Okay. So your virtual machine, for example, that you create using your VirtualBox, it's actually created from those resources. Okay. Your computer has two OS, one Windows, one Linux, and the resources, part of the resources has been used for your Windows, and part of the resources has been used for your VirtualBox for Linux. So you can see that actually it can be happen because of the virtualization layer. And how to support the virtualization layer is because of the hypervisor. So like I said before, my computer support hypervisor. So what is hypervisor? Is actually a low level program that can provide the system resources to your VM. Okay. So if you look more about the hypervisor, where is the location of the hypervisor? This is the location of the hypervisor. What do you think? Your type in your computer, type 1 or type 2?
Type 2.
Yeah, type 2. Because your host operating system is the Windows, right? And then there is another layer, virtualization. So we call it as hypervisor there. So on top of the hypervisor, there are guest OS. So for example, your Linux, the Ubuntu is your guest OS. So it is on top of the hypervisor. So this is very important to have visualization in your computer in case you want to import, you want to divide, your resources. So you need to visualize the resources you have so you can package that resources into a new machine, virtual machine. So that's why you can install VirtualBox and get a new OS on top of your virtual machine because of the virtualization. Okay, so lastly, this is just for not just to throw the idea, not homework, because this is our last class. That is maybe no homeworks. So this is just for you to think. Okay, maybe in the future you want to go to the cloud computing. So these are the things that you need to get to identify, to think about before you moving to cloud computing platform. Okay, so far, is there any questions for cloud computing? Okay, girl.
So far, okay. So far, okay, Doctor.
Okay, Doctor.
You get the main idea, right? Cloud computing. Just to get this is for introduction only. What are the characteristics? What are the deployment model? What are the service that they can offer? Software as a service, infrastructure as a service, or platform as a service. And then what are the technology that can support that? The load balancing and also the virtualization. And you can see the virtualization technology in terms of the hypervisor. And I think most of you, if you can install VirtualBox, it means that you have the hypervisor in your computer. So I think it's no time to do Kahoot, but I will try to get the link for Kahoot for the self exercise, okay, so that you can do anytime after the class for your self revision. And a big announcement here before I end my class that now in week 10, next week will be week 11. So we will have quiz 2 for next week. Okay. I just want to ask, on the same time today, on Tuesday 4 to 6, you are all free, right?
Tuesday 4 to 6 is next week.
Yes.
Same time as today lah.
Yes.
Should be free.
Doctor, I thought next week is minggu camp komputeran.
Yes, I know. Yeah, that's why I asked. Do you free? All of you free at that time, 4 to 6? Ada yang program dia ada pada hari Selasa tersebut, pada petang tu? Sampai pukul 4 hingga 6 ke? Ada ke yang programnya on Tuesday from 4 to 6?
Tu tak free.
Ada program tu, camp komputeran on that day?
29 bulan kan, 29 ada kot.
So you have program on that day. 29.
Yes.
Okay. So in that case, kan kebetulan until when?
If I'm not mistaken, till 31.
Until 31. Okay. So so it means that some of you is not free, right? On 29. Okay. In that case, we will maybe just look for the announcements in UKM Folio and in Microsoft Teams. Maybe one possible time is at night from 8 to 10. Is it okay?
Yes.
Yes.
Okay. So so that all of you can go to that quiz. So just look into the, I will announce, insyaAllah. We will have, we will discuss with the team teaching, Dr. Darila, Dr. Akram, and Dr. Zainal for the time. So when we have finalized the time, we will let you know. But the quiz is next week. But the time, we will not yet confirm. Okay? Quiz 2 is based on tutorial 3 and tutorial 4. Any question about quiz 2?
Doctor, it's written quiz.
No, quiz 2 is for tutorial 3 and tutorial 4.
No. I mean in
Is
the
it
answer
objective?
format, is it objective MCQ or is it written?
Multiple choice question or subjective?
You want subjective?
No.
Multiple choice question.
No.
MCQ is better.
Okay.
MCQ.
Same like quiz 1. So for quiz 1, yeah, same like quiz 1. Multiple objective questions.
Okay, thank you, doctor.
For quiz 1 that have problems with me, that right? So please can we set time now? Yang ada problem quiz 1? Maybe sekejap, saya guna masa ni sekejap. Besok pukul 5 boleh tak? Quiz 1. Ada tak yang ada masalah itu quiz 1 kat sini? Okay, nanti saya discuss dalam WhatsApp group. Masuk please enter the WhatsApp group for quiz 1 problems. So I will announce that for quiz 1 problem, the date for to retake, not to retake. So do quiz 1 is tomorrow, 23rd of December at 5 to 6. Okay. Okay, lab test week 14. We will let you know the time. Because at that time that you don't have any class anymore. So maybe lab test 2 most probably is on the lecture date, lecture time. Okay, from 4 to 6. So any last question before we end our class? So this is our last lecture. Okay. Thank you all for coming to my class.
Doctor.
Yeah.
About the timing of the quiz, can you extend some a little bit more time? Last time is not enough time actually. Like
1 hour
last
is
time,
enough.
is it 1 hour or 40 minutes?
40 minutes for 40 question, right?
Yeah, the last time.
Last time is 40 minutes, yeah.
Yeah. So this time is how many minutes, Doctor?
Okay, same 40 minutes. How long do you need? 1 hour?
Can we get 1 hour, Doctor?
Yeah, Doctor. Including the submission.
40 minutes.
Why you need more time?
The
For the
submission,
submission.
Doctor. My Wi-Fi.
Sometimes it's got line problem.
Okay, I will discuss this with the team. our team. Okay, with Dr. Dalila, Dr. Zainal and Dr. Akram. I hope they agree with your suggestion to get 1 hour for quiz. Just pay for the best. Pay for that. Okay. 1 hour. Okay, because of the internet, right? Okay.
Yeah, to the internet.
Yeah, okay. We will, I hope, good news for you. I hope we can give you a good news, hopefully. Okay. So, any more?
Doctor, can I ask about the project?
Okay.
Do you mind if we refer our idea to you first before proceeding, or should we just proceed?
Who is your instructor?
Dr. Akram.
Yeah. So I think better to ask Dr. Akram first, maybe.
Oh, okay.
Because he the one that will evaluate you.
I see. Okay.
Yeah. So maybe he might give you the tips also to get a good marks. Yeah.
Okay.
Just with lecturers, if you have problems or something to ask, you just ask them. It's very to get because usually they will try to help you. Yeah. If they not reply, just remind that again. I'm sorry if I'm not reply your questions or any things about. So just remind me again. I hope I can answer that. Okay. Okay. Sorry for anything for the past 10 weeks in our class. So you can contact me using WhatsApp and also Microsoft Teams. Okay. Okay. Any more?
Doktor, saya nak tanya berkaitan dengan yang group project tu, kan kita kena buat model kan? Berkaitan model tu sebenarnya kena buat guna software ke, atau kalau nak buat sendiri, buat 3D model boleh ke? Ataupun memang kena software?
Nak you want to develop 3D model tu guna apa?
Maksudnya kita buat sendiri lah, guna papers ke apa-apa item yang kita ada lah.
Oh, prototype lah, physical prototype.
Physical prototype.
Before this, we allow for that because they can do it together in a group. But now, when we have discussed again with the lecturers, we decide that the student use 3D model tools. Is it you have tried to see the available tools for 3D models?
Yeah, I got find some, but
is it difficult?
Boleh lah. Kalau untuk saya tak ada basic langsung berkaitan dengan science com. So bila saya guna software tu, saya rasa macam susah jugalah. Tak tahu dengan yang lain macam mana.
Maybe others can share also. Ada yang dah guna software apa-apa tak?
Doktor, kalau kita lukis sahaja macam mana?
So you want to draw?
Just draw the concept instead of doing the 3D model.
Okay. So I will also ask my teams, but I hope you also ask your lecturers. Okay. So we see how the feedbacks. Maybe if there are many suggestions coming from you, maybe it will influence our options to do that. Because now it's different than before. So yeah, maybe we will allow that too. So please, for me, I need to discuss first with the team teaching because I not actually conducted the tutorial, but some part I conducted actually with Dr. Akram. But for project, Dr. Akram we handle especially for group MM and IT. So we will inform you back if there is any latest news about the part, the 3D model. But I hope all of you also please ask individually to your lecturers, so that they will also see that the needs from the students, not only from me. Okay, they can also see the needs from all of you. So maybe they will get more information to make a good decision about that. Boleh faham?
Boleh.
Boleh eh?
Boleh.
Boleh.
Cuba dulu yang tu. Kita pun tak nak habiskan pelajar masa untuk develop yang makan masa kan. So we can see the options lah. So nanti beritahu pencara masing-masing. Based on the inputs, maybe kita boleh decide yang baru lah. Tapi tak pasti. So you just continue dulu apa yang dah ada. Siapkan dulu posters and all of the things that you can done by now. Okay? Okay, ada lagi soalan?
Doktor, want to check again, nak check sekali lagi, kita punya quiz 2 tu chapter 3 dan chapter 4 kan?
Tutorial 3 and 4.
Oh, tutorial 4, okay. Thank you.
Tutorial 3 and 4 tu, you also need to see the lecture lah related to that tutorial. Okay, if like tutorial 4 is related to OS design, right? So you also need to refer to the lecture for OS design.
Oh, okay, Doctor.
Okay. So, any more before we end our class?
Sorry, Doctor, we still cannot check the